So I'm going to do the problems on the 5th page of Unit 10 review. Okay, number 11B. You purchase 25 fish and then put them in a pond in your backyard. The table below represents the number of fish within the pond over a 6-month period. Determine the function that best represents the information from the table. Okay, so I start with 25 fish. I'm underlining that. It's a 6-month period. It doesn't tell me the pattern, so I'm going to look here. 25, 50, 100, 200, 400, 800, 1600. It looks like my fish are doubling, that everything is times 2. So I know that if it's a pattern where I keep multiplying by the same number or the same ratio, that must be an exponential function. So I also know that my exponential model is y equals a times b to the x. So I'm looking for the equation that's in that model. So it's not this one because it's linear. Okay, this seems to match my exponential function. And when I double check, this is squared, it's quadratic. This is 5th power, which we haven't talked about many of those. So when I look at this one, A is the number of fish I started with, which is 25. It's doubling, so there's my times 2 ratio, so it is B. All right, 12A, what is the percent of growth? So that's what I'm looking for the following function. F of x equals 14 times 8/5 to the x. So 8/5 is my B, so that is coming from, if you remember, if I take 100% or 1, and I add a growth rate to it, that gives me 8/5. So I could solve this by subtracting 1 from both sides, subtracting 1 from 8/5, and get that my ratio is 8/5 minus 1. Remember, common denominators, so I want to think of the 1 as 5/5. 8/5 minus 5/5 is 3/5. 3/5, if you punch it in your calculator, is 3 divided by 5. You get the decimal 0.6, and 0.6 is 60%. So that's number 2. Another way to think of this, when you do your 1 plus r is 8/5. If you think of the 1 over here as 5/5, you can ask yourself 5/5 plus what gives me 8/5, and go right away to the fact that it's 3/5 and then 0.6 and 60%. All right, 12B. What is the percent of decay now? So now it's going down for the following function. 900, f of x equals 900 times 3/4 to the x. So again, I'm starting with my 100% or my 1, and this time I'm subtracting something off to get 3/4. So I'm going to use the same idea as I did up here, common denominator. So if this is 3/4, I want to think of 1 as 4/4. So 4/4 minus what would give me 3/4. So that would be 1/4. 4/4 minus 1/4 would give me 3/4. I'm sorry, would give me 1/4. 4/4 minus what gives me 3/4, and that would be 1/4. 1/4 is 0.25, which would then be 25%. There's 25%. Okay, the last one, which of the following patterns are exponential? Select all that apply. So remember, exponential is common ratio. You're looking at the y values and you're multiplying them by the same thing to get to the next one. So 0.25 times what? Now remember, 0.25 is 1/4. So 1/4 times what is 1 times something, it gives you 4, 16. So it looks like, this looks like times 4, here to here, times 4, times 4. So all of those are getting multiplied by 4. So yes, it's exponential. When I look at number 2, and again, I'm going to keep going because it says select all that apply, so I want to look for all of them. So part 2, let's see, when I look at my y's, -8, -1, 0, 1, 8, I'm seeing a pattern, I'm seeing symmetry, and if it's symmetry, remember that's a quadratic. So I'm looking for an exponential, so it's not that one. Okay, 0.2, 0.6, 1.8, 5.4, 16.2, I'm thinking that it's times 3. And if you're not sure, remember the way to double check is to go backwards. Do 16.2 divided by 5.4 and see what you get. And I believe you should get 3. So 0.2 times 3 is 0.6, times 3 is 1.8, times 3 is 5.4, times 3 is 16.2. So that works. I have my pattern that I'm multiplying by 3. They have the same ratio, so yes, it's exponential. And when I look at this last one, 1, 3, 5, 7, 9, they're going up by 2, but I'm adding 2, so that would make it linear, so that one's no. Okay, the second one for 13b, let's see. 0.5, 1, 1.5, 2, 2.5. Those are going up by 1/2 or by 0.5, but it looks like I'm adding that. So not exponential. When you're adding, it's linear. 12, 24, 48, 96. Those look like I'm going times 2, times 2, times 2, which would make it exponential. 0.4, 2, 10, 50. I believe that one's times 5. If I keep multiplying times 5, I get to the next one. So yep, that one's exponential. 81, 27, 9, 3, 1. They're getting smaller. So I know lots of you like to say, you see the pattern and you said it's dividing by 3, but remember, the pattern has to be multiplying. So dividing by a number is multiplying by its reciprocal. So since those are times 1/3, then yes, that one works too. So that's the end of that page. That's the end of page 5 in the Unit 10 review.